kids, this is Miss Vada. We're going to try to finish up the whole back side of your guided notes so you can go ahead and get this finished and out of the way. And I'm going to put this on YouTube under, I think I've listed Heat Continued. It may be chapter 13, Heat Continued. I don't know. I can't remember. Anyway, here we go. All right, remember we have our three types of energy transfer, which are radiation, conduction, and convection. With radiation, that's the transfer of thermal energy by electromagnetic waves. An example would be a microwave or a heater. In thermal conduction, this is the transfer of thermal energy from a material. There has to be direct contact or touching taking place. An example of that would be a spoon in hot soup. And then the third kind, which is convection, is the transfer of thermal energy by circulation or movement of a liquid or a gas. And a good example for that would be boiling water. All right, then under our conduction, we have to define thermal conductors and thermal insulators. So, a thermal conductor is any material through which energy can be transferred as heat, or through which heat can be transferred. Three examples would be metal, iron, copper. Next, we have define a thermal insulator. This is a material that reduces or prevents the transfer of heat. Three examples of that would be wood, plastic, glass. I think I added air and cloth. Now, when we talk about greenhouse effect, remember we studied this in one of our previous chapters. But this is when the atmosphere traps energy from the sun. And when we studied this before, you know there are three main greenhouse gases. Those are water vapor, carbon dioxide, and methane. Now, the one that we tend to put more of into the atmosphere, of course, is carbon dioxide. Okay, then we move on to thermal conductivity. This is when the rate at which a substance conducts thermal energy. The rate at which it lets thermal energy move through it. Now, objects with a higher thermal conductivity like metals transfer energy much more rapidly to your hand when you touch it. This was when we talked about the metal buckle on a seatbelt and the cloth of the seatbelt itself. So specific heat goes right along with this. Specific heat is the amount of heat needed to raise 1 kilogram of a substance 1 degree Celsius. Now you can see your chart down here. This is the same chart that we looked at in the book, and you can see on the left hand side we have all of our metals: lead, gold, copper, iron. There's the metal of the seat belt. And then on the right hand side we have what would be considered more insulators: glass, aluminum, the cloth of the seat belt, and then you have ice, and then you have water. So if you look at the specific heat of water, it's a lot higher than all of the other numbers that you see in this chart. Okay, this is the reason it takes a swimming pool so long to warm up, because of those hydrogen bonds that have to be broken. Then the water can start heating. We watched that good video on Edpuzzle that showed that. You can even go back and watch it yourself if you need to. Oh, got to stop for a second. Phone's ringing.